This is VisualSwift version 0.6 build 4. And you can see a synthesizer created with the VisualSwift, which I'm playing using the keyboard. This is like a magic keyboard. You can see some visual feedback showing messages flowing through the schematic. This K component is where keyboard events come in. Then this component converts it to MIDI, and then it goes inside the synthesizer, which at the top level has a vertical stack. This triangle here is how you go inside, which is currently open. If you scroll down, you'll see the inside, what's inside it. But you can also close it, and then you don't see it. You can go full screen by clicking on the top left corner of the component, and this is front panel of the synthesizer. There's some presets. To minimize it, at the moment you click this blue X, and it goes back to the canvas of the component. So you can also play on this piano keyboard instead of going through the keyboard component that accepts events from pressing keys on your normal computer keyboard. So let's see the components we have here. We have an audio out with a switch, so you can switch the audio in and out. And this has a purple input component, which stands for an AV node. You can see here in this component, you can see the labels. You can switch labels on and off with this L. The X is for deleting the component, and the other button is for maximizing and minimizing. So like this component is minimized, I can maximize it. This is the maximized version of the component. To drag it around, you click on the orange icon. The same with this component. If you maximize it, this is converts mono to AV. I kind of prefer to have them minimized and without labels. So what's happening here is you have MIDI events. You can see them. You can see them highlighted when they flow through a link and through connectors. They're going inside this instrument, and then these blue outputs are for mono, for left and right channel. Then they get converted to AV, and this is a reverb component, which accepts AV input and sends AV output. And this knob controls how much reverb. This is no reverb. This is 100%, somewhere in the middle. Okay, so what else can you do? So after you create a synthesizer, you can this is how it goes inside it, and I'll explain what's inside it. But you can generate an Xcode project, which you can then build by so creates this VS instrument file, zip file, that you can airdrop it to a MacBook, open it up, build it in Xcode, and then you have your instrument as an AUv3 plugin, which you can then host even inside VisualSwift, which I can show later on as well. So, but maybe what I'll do is I'll create now. I could create a new synthesizer from scratch, which I will do in a moment. But maybe I'll show a few more features here. So, canvas scale affects the scale of your synthesizer canvas. So like 100% would be how it would show at this size, but you might want something more like this. This is how it would appear in a bigger screen, and it's more useful to see it like that in a schematic. As you can see, if I maximize it to a bigger screen, you get something more similar to this. So inside each component, which you go inside with this little triangle, you have panels. Like some components have a schematic panel, which shows what's inside them, and this is hierarchical. You can keep going inside components that are inside components. It looks complicated, but it's not as complicated as it looks. It actually simplifies, which when you create your own synthesizer, you'll see that having this hierarchy of components allows you to isolate complexity and reuse, and things become simpler. Okay, so the VStack has these three panels, which is the schematic panel, properties panel. These are related. Leading, center, and trailing are related with your alignment inside the VStack, and the spacing between the elements. And then this code is generated, so you don't need to worry about it. It's here more for debug purposes, but this is the code that goes into the Xcode project for building an AUv3 plugin. And there are several parts of the whole code, like Swift UI is related with the UI, and then the kernel is the actual low-level audio code. The params are related with the parameters for the presets, etc. These are the presets. There are 5: first, second, third, fourth, fifth, and you don't need to worry about them because you create your own presets by interacting with the front panel of your synthesizer and saving the presets. So there's a sidebar on the left side. This is where you would have your libraries for AV, MIDI, like for example float. You can drag components from here, like for example to drag a knob, you drag it to your schematic, but you don't need to go to the library very often, because when you drag from an output, it shows you the components that are available. Like here, for example, if I want to show the float value, I'd create a show component, and that shows us how much reverb we're using. This float value goes to the reverb component. So this way you could see how much. So it's not that often that you need to go to the sidebar, and that's on purpose. Also, you can create components in the schematic by double tapping, and there are some components that make sense when on an empty schematic, like we've seen the key component or a piano component, etc. So the idea is to not need to go to the sidebar, but if you but if you do, your libraries are there, and at least you can see which components are available. There's a bundled sidebar, which will have ready bundled modules that you can use, like an oscillator. You could drag it in and use it in your own synthesizers. This will evolve over time, and hopefully there will be good modules to use, useful modules. There's also a custom, and here you put your custom module. So when you create a module that you think you might want to reuse later, like for example, let's say this one, an oscillator and an envelope, you drag it to the drop area, and then later on in another schematic you'll be able to bring it out. And for some reason that didn't work. Let's see here. Okay, so that's a bug. Let's see another one. Also didn't work. Oh, let's see, maybe. Oh no, that's annoying. Okay, so that's what that one would be. I'll need to look at that. That has been working, but something must have got broken in the latest release. Now, each of these components you can delete, or you can share, again, airdrop to another device to use there. So that's your custom components. This debug is just for now. It helps debug reference counting, just to check that everything is cleaned up. So when you close and open a schematic, it should, these numbers shouldn't go up, because if they go up, it means the previous project wasn't cleaned up properly. And at the moment it seems to be working fine, but I'm leaving it here just to help debug. In the final release it's not going to be there. Okay, so I don't know if I should explain the libraries like MIDI. It's obvious, piano. These two are quite important. The views and the modifiers, they're related with the UI, and they follow the Swift UI. So like here you have the stacks, this stack, this stack, you have text, you have color, you have button, and then modifiers are, they modify the views, like with the corner radius, with the background, with some padding, etc. So now I'm going to close the sidebar and maybe start with a new schematic to create some very simple synthesizer. So close this project and start, and maybe I'll show, for example, hosting. This is like how you would host. Here it's hosting an instrument and an effect. You can also make this full screen, like for example the effect. And there's an X on the top right to go back, and also with the instrument. And you can see that there also here there's like a keyboard component where these are keys coming from the iPad's Magic Keyboard. They're converted to MIDI and then they go to the instrument. Now this instrument component, when you go inside it, you see a list of available instruments on your device, which you can choose from. This one at the moment is showing Lagrange. I guess it should show the name on the component, so maybe in a future version I'll make the I'll make it obvious which one is being used. So the same thing for an effect. You see the effects available, and then you plug them. They have AV inputs and outputs, so quite easy to plug. So that's hosting, and you could host plugins that have been created with VisualSwift, like here. This plugin has been created in VisualSwift, but you see when you go inside it, you don't see all the modules because this has been exported as an Xcode project and installed on the device, and now appears as a AUv3 instrument. Now, like if you'd want to put some reverb, you would disconnect your AV, connect. Actually, reverb should be showing here, but it's not. But this is a good example to show. Go into the sidebar, dragging reverb in. Now you don't need sidebar. And then connecting your reverb. And then I'm going to put a knob. It's not here either. Again, go to the sidebar. Bring it back in. Now connect the knob to the reverb. And I tend to switch the audio on and off to make sure it picks up the changes. But in the future, hopefully that won't be necessary. So now no reverb. And now with reverb. And here. Okay, so this is hosting an instrument created with VisualSwift. And okay, this is just another example of hosting. This is an example of hosting multi output. This is EG pulse with multi output. You can see the connector for multi output is different from the normal AV, and it can be split into channels, which you can then use separately. So channel 1 is the kick, and the other sounds they don't play because they come out from the other channels, which you could connect to an EQ, each one to their own EQ, and process them separately. Okay, so maybe I'm going to start a new schematic. When you're creating a synthesizer, at the moment the best is to start with a VStack, because the VStack at the moment it's the only one that allows you to make it exportable. But HStack and ZStack will also in the future will also have the same, but for now only VStack. So here, this is the beginning of the content of your of the panel of your canvas on the VStack, and this is the modifiers, beginning of the modifiers, and they plug in series. Like for example, if you put the knob, you see it appears on top. Because this is a VStack, if you'd put another knob, they would appear vertically. You see here the Swift UI codes is building according to these changes. Now, if we'd want the knobs to be horizontal, then you would use a HStack, like for example HStack, and now inside your HStack you would put two knobs. Oops, did that wrong. I wanted a knob there. So knob and another knob, and now they appear horizontally. These ones we don't need, delete. So this is a V stack that has a H stack. Now if we put another row of knobs, they would appear underneath the other row. And there's a quick way of doing that. On the top right you can drag out from and create a copy. And now if you connect them together, you have a V stack with two H stacks. Like if the second row we would disconnect one knob, then you'd have just one knob on the lower row. Now I'll show the modifiers. For example, this modifier affects the V stack because it's directly inside the V stack. So we could give it a background. You can see it affects the panel above. And let's give it a corner radius. You see the corners are now round. These components are minimized. If you want to change the color, you can maximize it by clicking on the orange icon and then the middle button, action button, and then you go inside your background color, and here you'll be able to add it to something else. And now I'm going to close it there. And so now, for example, on the second row, if we change the color of the second row, like background, again here we have to maximize. Now the color, give it some different color. And we could give it a corner radius as well. Also we can give it some padding. So we want first to do padding and then give it the background, so that the background goes through the padded area as well. So this is how you would start building your UI. Now for this VStack to be exportable as an instrument, it needs to have a MIDI input and two mono outputs. So inside it, if you double tap on the schematic, you can give it an input. This connector shows that this is a trigger. By default, they start as trigger, but we want it to be a MIDI. Also, this component is minimized, and to change the type, we'll need to maximize it, go inside it, make it MIDI, then we can minimize it again. Actually, that's a bit of a bug there, but it's okay. So same for output. We go inside and make it a mono. Now before we minimize it again, we can create a copy. So we have one for left, one for right, and now we can minimize these. Minimizing, I prefer to have them minimized because it saves a lot of space, makes it a lot easier to understand schematics, because you see more of these modes, and content can also be minimized. And the background can be minimized. So now we see the modifiers here are a blue background and a corner radius. You can see by the orange icons what they do. Here also you can see by the icon on the input to the left of the component, and you can see the icon meaning output on the right of the mono connectors. So this is an instrument that doesn't have any sound for now, but we can plug it on top, make it ready for having sound. So what we want is to have either a piano or a key input event. I'm going to do a piano here. So when we click on a key on the piano, you can see the connectors and lines get highlighted, and also it flows inside this input, and you can see the input down here also gets highlighted when an event flows through it. So this is the input of our instrument, and now as for the output, we want it to go to audio. We want to convert it to AV. These are mono audio rate streams, and we want to plug both to this component, which converts to AV, and then the AV we can make it go to audio out, and that's it, ready, but making no sound at the moment. I also like to put the key component, convert it to MIDI, plug it, because this way I can use the keyboard, like the Magic Keyboard on the iPad, to play, and I don't have to be touching the keyboard on the screen. We could go full screen with this, but at the moment no sound. Now I'm tapping on the keys of the Magic Keyboard. You can see events flowing. Okay, so to start creating a synthesizer, let's start with a simple sine wave. So our MIDI events we convert to voices. This component converts each MIDI note to a frequency, and in future we will be able to configure it for different kinds of tuning, but for the moment it's fixed on normal tuning. So it's a V connector, which means voices, and it has like a white middle. It's poly, so these are poly voices, and we can convert it to. So this component, I'm going to maximize it. This component converts the voices to polo events. These polo events, I'm going to show the labels. So these polo events are gate, frequency, pitch, and velocity, and they work per voice. And at the moment there's only 4 voices supported, but that's just for now, because in the future you'll be able to select how many voices. So like the frequency, we can convert to this white poly. So this white poly connector means streams of audio per voice. So it's polyphonic, while these blue ones, they're monophonic. So here we have, and the green events, they're discrete. They only they happen not very often. They don't run at full audio rate, so they don't take much in terms of resources and CPU. Mainly the white poly connectors and the mono connectors, they're the ones that run at full audio rate. So now we have a frequency available for polyphonic audio rate. We can connect it to a sine component. This is the minimized version of the sine. Maximized version is this, with the name sine. So the sine. So now we have, when we press the key is converted to MIDI. MIDI is converted to voices with frequencies. The voices are split into gate, frequency, pitch, and velocity. The frequency here is connected to an poly audio stream, and there's 1 frequency per note. And now our sine waves, to connect to the left and right channel, we need to sum them all because we have several voices. Now I'm going to connect to both the left and right channel. It's not stereo. Both channels will have the same. Now I'm going to switch audio on, and now we can hear our sine waves. There are 4 sine waves playing. Could switch it off. So there are 4 sine waves playing. They're playing, constantly playing, even when you're not pressing a note. So this frequency will change the voice's frequency from whatever was the previous frequency, but at this point we don't have any ADSR, so like an envelope, attack, decay, sustain, release, so that we hear the note coming on and going off. So I'll do that next. So before we sum, I'm going to move this to the right. Before we add all the voices together, while it's still polyphonic, because we want the envelope to be per voice, we can connect it to an ADSR. So we can multiply it with an ADSR. So we need to go and go to the libraries and find an ADSR there in poly. There. So this is our ADSR component. So we connect it to there. Now we have sine wave multiplied by an ADSR. This is our envelope, which accepts poly grain inputs. We can look at the labels. Again, we have gate, attack, decay, sustain, release. I'm just going to plug the gate for now. And let's see what happens. We don't need sidebar. Switch on audio. And now I'm playing on the iPad's keyboard. And we can see we have envelope. It does have default values at the moment, but we have input connector here ready to feed other values for attack, decay, sustain, release. So maybe I'll show how to do that next. So let's say we want 4 knobs: attack, decay, sustain, release. Let's say we want them in a row horizontally, so we need a H stack, which is here, H stack. Now inside our H stack, we can go inside it and we can now connect 4 knobs. 1, 2, 3, and 4. Okay, so this is our row for attack, decay, sustain, release. You can actually go inside each of them and give them a label. Let's say A. And while you're there, you can also give it a format to show the value. So percentage point 2F shows 2 decimal places. So here as well, decay, percentage point 2F, sustain, and percentage point 2F, and now release and percentage point 2F. Okay, now we need to send the values from these knobs up to 1 level up, so we can connect them to our ADSR. Also, the knobs send out a float value. You can look at the value with a show component. And what we want is a polyfloat. So we'll need to convert these floats to polyfloats, meaning the value is repeated in every channel. So I'm going to delete this component And now I'm going to convert to polyfloat, attack to polyfloat, and now decay to polyfloat, sustain to polyfloat, release to polyfloat. And now to send them one level up, we need this to go to an output. And now you can see it appearing there. That's the attack, decay, sustain, release. And now for debugging, you can move the knobs either down here or up one level up. It doesn't matter where. And you'll see the visual feedback where they go red. So you can make sure they're connected to the right one. And now we can connect our attack, decay, sustain, release. Now this component it's quite a useful one. So you can go to your custom and drag it in. We need a way of changing the name. So another thing I need to do, so that in future, which I think we found out earlier that this is not working, but you'd be able to drag it in and it should create it. And that has been working, but somehow it must stopped for some reason. Okay, so we have our envelope plugged. So this is the UI. Green components are events that go into the ADSR component, which is connected to the poly audio stream, which multiplies the envelope by the sine wave, and all the waves are added up, and then they go to the output. Now, these knobs I did before just to show how to do an UI. We don't really need them, so I'm going to plug it to our ADSR. And now I'm going to switch the audio off and on. Now play. So like very low attack and a high attack. And a low attack, low sustain. And you could go full screen. Sustain up, slow attack. Okay, so this is our simple synth. We don't need these ones. So this is very basic, but you just continue like this, creating filter with an envelope and all that, and you would eventually end up with something. This is still quite a simple synth. Okay, I think something is wrong. When you hear sound like this, it's when it didn't clean up properly. Doesn't happen very often. I think it's because of new components that I've just created today, which are not cleaning up properly. So what I'm going to do is kill the app and start again. Okay, so after a simple thing, you would continue something like this, or even more than this, but you can maybe now understand that this is a VStack, you go inside it, the VStack, this is your UI elements are connected to this one here, so you can see in vertical order you have a preset component. Then you have this hedge stack and another hedge stack with oscillator envelope, and the second row filter envelope, the filter and the output gain, as you can see up there. And then the same thing for the second voice, which you can detune. And okay, I just think, but that's basically that's what VisualSwift does at the moment, in very basic terms.